Hello everyone. My name is Olivier Grisel. I am a software engineer working at INRIA. I've been working on the scikit-learn project, open source machine learning in Python since its foundation 10 years ago, and 7 years at INRIA. And more recently, my work is supported by the help, the financial support of private partners and public partners also via the INRIA Foundation. So thank you very much for them, because otherwise this presentation would not be possible. And so initially for this presentation, I wanted to introduce how the open source collaboration work in the case of the scikit-learn project. But then I changed my mind and decided to tell a more personal story to highlight the value and the long-term value of the long-term cross contribution between open source projects. So I will explain how an open source project contributors like myself can work together with other maintainers from other projects in the Python ecosystem. So this particular story starts in October 2017. At the time, I was working with the dask cluster system, the dask distributed computing system for data science workflow. I was trying to make scikit-learn models train on a bigger data set distributed on different machines. But then I quickly faced a problem with my pipeline, and I experienced that some dask worker would randomly restart, and then that would prevent my job to complete because they could never finish their subtasks. So I had to investigate the cause of the problem, and I discovered on the issue tracker on GitHub for the dask project that other people had experienced similar problems. Then by reading the discussion, I discovered that the source of the problem was the unusual memory usage on the worker that was beyond what would be expected for this specific pipeline. And over time, that could cause the cluster manager to restart the workers because they would use too much memory. That by looking into the code, I found out that indeed the way the garbage collection of temporary buffers was done would not be aggressive enough. And by tweaking the code and the heuristic to do this, I could make my worker work better. And this improved the things a lot, but I still had the problem on some occasions, but it was much rarer than previously. So basically, we had a bug in dask that was hiding a bug somewhere outside of dask. And then to fix the remaining bug, I had to understand how dask would ship Python objects between worker nodes. And this happens via dependencies between dask components. And upstream project. So in particular, dask relies on pandas to build these distributed data frames. Pandas itself relies on numpy for the memory buffers that are used in the columns of the data frame. And when you ship data from one worker node to another, it's built upon the pickling module of the Python standard library, which is extended further in cloudpickle to be able to pickle interactively defined Python objects, for instance, in Jupyter sessions. So those kind of objects are not directly pickleable by default, so we have some extensions in cloudpickle to do this. So in this specific situation, the problem was that under high memory pressure, the dask worker start to dump numpy arrays to disk. And to release some memory. But by doing so, the pickling process, so the serialization of those numpy arrays to the disk, was actually increasing the memory usage because the pickling process itself was triggering a memory copy, which had no reason to be there. It was just because of limitations of the way pickling is implemented in general and in numpy in particular. And some of those extra memory copies would trigger the limit and would trigger the restart of the worker and would prevent my pipeline to complete. And so by investigating how pickling was implementing in Python, in cloudpickle and numpy, I discovered that there was no natural way to pickle read-write buffers without making those extra copies. And so it was a design limitation of the pickle protocol itself and its implementation in CPython. And furthermore, I discovered that it was not only a problem with NumPy, but also with simple read-only byte arrays in pure Python. The pickle module will trigger those additional extra copies for no sensible reason. So that was kind of frustrating because it's a limitation, a fundamental limitation of Python. So this was in December 2017. I decided to report the issue to the Python core developers with respect to the issue just for Python arrays without NumPy, the read-only arrays. Okay, and by reporting the issue, I dived into the problem, and actually I found out that it was not too complicated to contribute to Python to actually fix this. So it was the first time that I had to write C code using the Python API. But it was not too complicated, and with the help of Antoine Pitrou and Seri Storchaka, who are core contributors of CPython, so the Python interpreter, I learned a lot in doing so, and I could successfully fix the bug for the Python case. But then we still had the problem with NumPy, and so I fixed for the pure Python object in CPython, but for NumPy buffer, it's slightly more complex because they are read-write buffers, and then the pickle protocol implemented in CPython was too limiting. I could not really fix it without breaking the protocol. So what I decided to do is to find a workaround in the cloudpickle library. I happen to be a core developer of this library, so I could fix it there and find a workaround. So this is what I did. I implemented this kind of workaround using a hack, basically, to implement no copy semantics for large memory views because I had more control on this library. To do so, I had to do some weird low-level hack to check whether or not it's safe to mutate a buffer that was allocated by the Python interpreter. Normally, we should not be able to do that, but then I could retrieve, in some cases, if I could detect that there was no other reference to that object, I could retrieve basically the memory address and wrap it with an NumPy array and then avoid the memory copy. So it was slightly more complex than this because at the time we wanted to support all versions of Python, so like Python 3.4, and in this case I had to do a weird hack to make sure that the garbage collector would work appropriately. Anyway, so I was very happy with this because it was working, and I had fixed my problem. No random restart on the dask cluster anymore. And furthermore, I had a review by another very experienced core developer of the cloudpickle project. I was very happy because he was also finding that this was impressive work. So basically, the two of us were happy together online of this clever hack. And nobody else will understand this piece of code because it was too complex. But I decided not to merge it because precisely it was too complex, and I feared that it was not a good idea on the long term to accumulate this kind of hacks, low-level hacks. So instead, I waited a bit and hoping that there would be a better way to do it. And in March 2018, actually a better way emerged because when speaking with Antoine Pitrou, the Python core developer, on my first contribution for the pure Python object, he realized that the pickle protocol was really too limiting. And that would be a better way to refactor it and to extend it a bit to make this kind of use case much more naturally to tackle, much more natural to tackle. So he proposed a new specification for an extension of the pickle protocol that the core developer of Python will discuss together based on my experience of my bug report. Basically, I was providing some kind of use case, and then they realized that the design was too limiting and we could not properly address my use case, and so make the design evolve. And as in parallel to implementing this, providing this specification and the implementation in the Python project itself, he provided a backward compatible implementation as a module, which was called Pickle 5, that could be installed on previous versions of Python, on released version of Python, so that other people could experiment with it and see if that could make their project work better. So that was very nice, because then in May 2018, before the Python project has even accepted this protocol design, we could experiment with it. And in particular, now we could focus on the numpy side and try to change the way numpy pickling is implemented to use this new functionality if it's available, if your version of Python is recent enough, or if you had implemented, installed this backward compatibility implementation. So I opened the issue on the numpy issue tracker to advertise that would be a better way to do it. But unfortunately, none of the NumPy core developers had the time to have a look at it. I just provided a high-level proof of concept pure Python implementation to show that it was actually beneficial to do it, to avoid memory copies. But then nobody had the time to actually work in the NumPy internals, which are written in C for this specific code. And myself, I did not have the time also to work on that, and so nobody was doing the work. So some time passed, and in September 2018, we had hired a new engineer in the team at INRIA to work on low-level problems, long-term problems for the scikit-learn project. And so this was one of the tasks where he could work and focus his time on working on this. And so he implemented this and contributed to the NumPy project as a pull request. And then it was quickly reviewed by NumPy core developers and also Antoine Pitrou from CPython. And then accepted, and we could prove that it was actually very beneficial from a memory usage point of view, provided benchmarks and so on. And so based on this successful story from the NumPy point of view, Antoine Pitrou also started to contribute it to other projects, such as the Arrow data structure that is used by many big data frameworks that interact with Python one way or another. And then in the discussion, you can see that Wes McKinney, with the original author of the Pandas library, faced the same issue at the beginning of the Pandas project, but did not have the time or will to invest the time to fix it properly in CPython, and was very happy to see that this 8 years after, this problem was finally being taken care of at the Python level itself. So that was really worth it, because it was not just beneficial for NumPy, but also for other projects in the Python ecosystem. So in June 2019, then the PEP, so the specification of the evolution of the pickle protocol was finally accepted by the Python developers and accepted. So this is really nice, because then now we have fully resolved my original problem 2 years later, just by upgrading your Python version, your NumPy version, and your cloudpickle version. And this bug was also fixed for many other projects, such as Arrows and possibly other projects in the future. Okay. So is this the end of my story? No, because meanwhile, in February 2019, we had other issues as part of the scikit-learn project. And in particular, in scikit-learn, we use a component called Loki, which is doing the same kind of thing as distributed, but on a single machine. So it's a simpler version to do, a simpler component to do multi-Python process programming, but on a single machine. And this is typically useful for scikit-learn for accelerating some algorithms on a single machine. And this component is also using cloudpickle to ship Python object between different Python processes. However, when working on this, we knew because of the way cloudpickle was written that the speed, the communication speed between the Python processes was much too slow than the theoretical performance, because cloudpickle is using a Python implementation, a Python subclass of the pickle implementation in CPython. And in particular, a Python subclass of the Python implementation of the pickle protocol in CPython. And if we want to use the faster C implementation of the pickle protocol, we could not do it because the C implementation here was too limiting. It was not flexible enough. The Python implementation had more flexibility, so we could extend it in cloudpickle to provide the additional features that we needed, but this was too slow. So thanks to the fact that Pierre Glaser, our engineer at INRIA, had the first experience with the low-level internals of the pickle protocol in the C library, in the C implementation in the CPython project. Based on that experience, we had the confidence that we could propose an evolution of that implementation, of the C implementation, to make it much faster to serialize Python object. So it's interesting because both myself and Pierre at the beginning, we did not know much, anything basically about CPython internals. But thanks to the first experience we had to collaborate with Upstream project, we were now able to think and find a way to make that work much faster than what's previously possible. So we started to prototype this. Actually, Pierre did most of the work, and to contribute to CPython to some evolution that would make our thing in cloudpickle much more efficient. And because we had already interacted with Antoine Pitrou, we had very nice productive collaboration with the Python core developers, and this was accepted. We changed the design twice based on the Antoine Pitrou very interesting feedback, but in the end we finally found a good design that was not too intrusive to CPython, but still would allow the flexibility that we needed to make it much faster to pickle object in cloudpickle. And so we had several pull requests basically to fix this in CPython. And by October 2019, Python 3.8 was released, and then cloudpickle, when you use this version of Python 3.8, can run much faster than previously, like 10 times faster. Instead of being CPU bound by the Python process, now you could, in some cases, be IO bound for the communication between workers, which was what we wanted from the start. So this story is just a way to highlight that open source is really not a zero-sum game. It's really a collaboration where you can invest your time in people by doing code reviews. And this is on the long term highly fruitful, because, for instance, the code reviews that we received, Pierre and I, from Antoine Pitrou and other numpy and CPython core developers, really educated ourselves into the internal details, and really we could discover that something that would think was not possible was actually possible, and thought about things that would really greatly improve the experience of our users. And on the other side, the fact that ourselves, from user-facing projects such as scikit-learn, we could discover use cases that were impacting the life of many data scientist users, and the C Python core developers were not necessarily aware that some low-level design decisions in C Python were impacting data scientist users in such a bad way. But they needed intermediate core developers like ourselves on scikit-learn and cloudpickle, basically to bridge basically the need of the end users with the needs to make the low-level specifications of CPython to evolve to fix their problems transparently. Because even the data scientists, they do not necessarily realize that they had those needs, and the memory usage and the speed of communications between objects. They would not necessarily realize that the previous situation was suboptimal because nobody had done this investigation, this low-level investigations. So having the opportunity at INRIA to spend some engineering effort beyond just scikit-learn developments, because we know that we are hired for several years, and that sometimes we can decide to invest our time in contributing upstream in open source project and not just in scikit-learn, is very beneficial. And this is very important because then this investment provide a shared understanding both of the technical details of the code of all the libraries of the stack, but also share the understanding of the final user's needs, and also improve the trust between the core developers of those different projects and the contributors of those different projects. So I would like to thank all the people who were involved in the pull request that I presented in this presentation. So Pierre, Joey, and Matthew in cloudpickle and dask, Antoine, Victor, Seri, and Terry from the C Python core developer team, and Matty Picus and Tyler Reddy on the NumPy side, because basically by taking the time and effort to review others people's code, we educated ourselves together, and we made the full stack work much better than previously. And as a funny side note, because Pierre had worked on CPython and NumPy, and myself also as part of these contributions, on the GitHub page, on his GitHub profile now, you can see that Pierre has actually contributed to the success of the Mars 2020 helicopter mission, because that NASA mission was relying a lot on CPython and NumPy. So now we get this achievement badge on our GitHub profiles. So I just wanted finally to highlight that the value that can be unlocked by this contribution and collaborations between different open source projects is only possible if we have long-term support to work on those projects. Because if I was working on scikit-learn just as a volunteer contributor, I would focus on short-term problems for the scikit-learn project only. But thanks to my employer INRIA and the financial supporters, we can have a more long-term approach on our investment on scikit-learn development, and think about the problems that will take years to resolve. Remember that this started in 2017 and was only fully fixed in the end when Python 3.8 was released at the end of 2019. So it took more than two years to completely fix this original bug, but then it was fixed for the much wider ecosystem and not just for my specific use case. So, and this is only possible because I have the ability. I am privileged to work at INRIA and to have the ability to think on the long term because I am financially supported by INRIA and those partners to work on this ecosystem and to make it work and maintain it to make it work better on the long term. So thank you again to those partners, and thank you very much for your attention, and maybe see you later on GitHub. Thanks.